Assalamu alaikum. We have studied an AC circuit containing a pure inductor in the previous video. In this video, we will discuss an AC circuit containing a pure resistor. For that, I consider a resistor of resistance R connected across an AC voltage source, alternating voltage source. Here, resistor of resistance R is connected to an alternating voltage source. The instantaneous value of alternating voltage is given as V, which is equal to Vm sine omega t. Here, V is the instantaneous value of alternating voltage and Vm is the peak voltage, peak or maximum voltage, and omega is the angular velocity, and here t is the time. So I take this as equation number 1. Due to this voltage, a current, an alternating current flows through this resistor. Okay, I'm going to get the expression for that instantaneous alternating current. According to Kirchhoff's voltage rule, what does it say? Kirchhoff's voltage rule. The sum of a product of current and resistance in a closed circuit is equal to the total potential difference. Total potential difference. When I say potential difference, it represents voltage or EMF. Okay. So in our case, the current flowing through this resistor is taken as I, which is multiplied with the resistance of this resistor, that is R, into R. Okay, this is the product of current and resistance in the closed circuit, and that total potential difference is nothing but this, taken as a V here. Clear? So we know the value of these two. We know the value of V. I am going to substitute that here. So what I'll get? I'll get this. IR is equal to Vm sine omega t. Then I'm going to make a certain changes to this. What I'll do? Here, my aim is to find the value of I. So I keep I here as such. R is taken to that side. So Vm upon R sine omega t. According to Ohm's law, when voltage is divided by resistance, we get current. Here, Vm upon R is found to be equal to Im. So here Im is the peak current or maximum current flowing in the circuit. Okay. So by keeping that in mind, I will become equal to Im. I take it as a small I. No, as given. Im sine omega t. Even if I take this one as a capital I, it is not going to make any difference. Okay, this is the final expression which represents the instantaneous value of alternating current in the circuit. Clear? I box this. And Name it as equation number 2. Here, equation number 1 provides us instantaneous value of alternating voltage in the circuit, and equation number 2 provides us instantaneous value of alternating current in the circuit. Okay, from this, if you observe these are two equations keenly, you will find that here the angle, phase angle, is nothing but omega t in both equations. So the phase angle difference is nothing but 0 here. This shows that instantaneous current and instantaneous voltage, current and voltage in this circuit are in phase. Okay, so I and V are in a phase because the difference in the angle between these two is 0. Okay, so they lie in phase. So they are in phase. Okay, this I'm going to show with the help of the wave diagram. I'm going to draw the wave diagram of this current and voltage. This is taken as a y-axis. This one is x-axis. Okay, along x-axis we take time angle, and along the y-axis we take voltage. Okay, so the sinusoidal wave which represents the voltage. Similarly, I represent the current I along y-axis. Alright. Now this is the waveform that represents current I. And this represents the voltage V. This waveform diagram clearly shows that the starting point of current and voltage is same. So from this we understand that the minima and the maxima, this is the maxima, the minima and maxima of current and voltage vary simultaneously. This is what we understand from the diagram. Now I'm going to draw the phasor diagram. For that I extend the axis. This is the x-axis. This one is the y-axis. Okay. Now I take a point somewhere here. It is around 45 to 50 degree. Around 45 degree. Here. Now we know the projection actually provides us the phasor. Okay. Different patch-ups I use here. First I'll start with the voltage. This is the projection. Now this is the origin. From here I draw a line here, named as OA. This line OA represents a phasor which provides voltage V. This provides voltage V. Voltage V. Okay, and here the angle that this phasor OA makes with the x-axis is nothing but the value of omega t at this point. Alright, it is around 45 degree. So this is the value of omega t. Whatever omega t we have here, whatever the value of omega t is here, the same has to be kept here. Okay, this is what we get. The next I'll use a different color chalk piece. from this point. I draw a line here. They call us projection. Okay. Intercept at this point. Now, from the origin, I draw another line. This I name as OB. This phasor represents a current I. Okay, it also makes it the same angle. So this shows that the phasor I and V are in phase. Okay, so they vary simultaneously. This is what we understand here. So in case of an AC circuit containing a pure resistor, the instantaneous value of alternating voltage and alternating current are in phase. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put your questions in the comment section. Thanks for watching.